Hello everyone, welcome back to our channel. We are studying class 9 physics, that is force and laws of motion. So, in the previous session we learned about the derivation of second law of motion, we learned about second law of motion, and we have also seen few numericals related to it and the derivation part. Okay, now in this video we will continue forward the second law, the concept of second law of motion given by Newton. Note that you will have to remember the formula of that force equals to mass into acceleration. Now based on the last formula, whatever we have derived, that force equals to mass into acceleration, let us obtain few extra information on force. So let us now obtain unit of force. So what is the unit of mass? That is kilogram. Unit of acceleration is meter per second square. Now if you put both these units of mass and acceleration in the formula of force, so that will give you force equals to kilogram meter per second square. So the standard unit of force based on the formula mass into acceleration is kilogram meter per second square, right? Now this unit is also named after a very famous scientist, Isaac Newton. So if you don't want to write kilogram meter per second square as a unit of force, you can also write it as Newton. The symbol for Newton is capital N. So instead of kilogram per meter second square, you may write only Newton. So Newton is equal to kilogram meter per second square, right? Now let us define 1 Newton force. This is very important as for exam purpose. Definition of 1 Newton force. How much is 1 Newton force is always asked in the exam. So for that we just have to put 1 in front of the physical quantities, that is Newton you put 1 over here, kilogram you put 1 over here, and meter per second square 1 over here, right? So this will be 1 Newton, this will be 1 kilogram, and this will be 1 meter second square, right? Now based on this small thing we will have the definition of 1 Newton force. Now this will be very easy for you, as you know what is 1 Newton, it is force. So what we are defining, we are defining 1 Newton force. What, how much is exactly 1 Newton force? What is 1 kilogram? That is mass. That what is 1 meter per second square? That is acceleration. So now based on these very easy things we will define 1 Newton force. 1 Newton is the amount of force that produces an acceleration of 1 meter per second square in an object of mass 1 kilogram. So if there is 1 kilogram mass heavy object, and if you give some force and which produces 1 meter per second square acceleration, that amount of force that you give is nothing but 1 Newton. Clear? Now applications of second law of motion given by Newton. Now first application, you see a cricket player, mostly fielder, moves his hand backward on catching a very fast coming cricket ball. If the impact is very fast and he did not move his hand backward, then what will happen? Due to less time the effect of force will be more, so he will be hurt in his hand. So to get rid of this impact he moves his hand backward. Okay, in athletics meet, in high jump, if you see specifically, the jumper is jumping and he or she is falling on a cushioned bed. So that cushioned bed, that soft bed, will take the impact and reduce the force. So he or she will not get hurt. The same formula, the same concept is applied on a long jump. That we have a bed of sand, so that jumper slows down while falling, right? And he or she is not hurt in his legs. Seat belts in cars are also related to this phenomena. Whenever there is an accident or impact, the seat belts will slow you down. So, if there is more time, the effect of force will reduce. Karate player moves in hand very fast to generate more impact, and to break the bricks or tiles, he need to generate more force, and more force is generated if you reduce the timing. So he moves his hand very fast. So these are few applications of the second law of motion in our daily life. There are many more. So you, whenever you observe, you just think it up. Now, on the basis of the formula F equals to ma, we may have few numericals. For example, calculate the force necessary to produce an acceleration of 3 meter per second square in an object of 10 kilogram mass. So you are finding force. So before you solve any numerical, just make the list of what is given. So mass 10 kilogram is given, acceleration 3 meter per second square is given. Now the formula is force equals to mass into acceleration. Put all the values, it will be 10 into 3 and that will be 30 kilogram meter per second square. Now you know that if you don't want to write this lengthy unit, you may just write it as 30 Newton. So this is a very simple question asked on the basis of second law of motion. Now let us see the second type of question that may be asked, but this time it will be little bit twisted. What will be the value of acceleration if 60 Newton force is applied on an object of mass 10 kilogram? So here mass is given, acceleration is not given. We are finding acceleration. Force is given, that is 60 Newton. Applying the formula F equals to ma, we have to put all the values that is given. Force is already given 60, so I have put 60 over here. Mass is 10, so let us put 10, and acceleration it not given, we are finding, so put a. Now this 10 over here must be taken on the other side to find out the value of acceleration. So if 10 goes below 60, the value of a will be 60 by 10, and that is 6 meter per second square. Note that here what we are finding acceleration, so don't just put the value or unit of force. Here the unit will be only meter per second square, right? So these type of questions may be asked which is on the basis of second law of motion. In the next few videos we will discuss about other type of numericals as well. So for this video, that's it. You just make proper notes and do proper calculations. Thank you.